What's up, everyone? Kya hal chal? Welcome to today's explainer. Today we're going to decode a legendary text, Chapter 4 of H.C. Verma, The Forces. Bina kisi tension ke, we're doing a clear, mentor-style breakdown of the fundamental physics rules that literally run our entire universe. Chalo shuru karte hain.
All right, let's just dive right into our roadmap for today. First, we'll do a quick intro to forces, then sequentially break down gravitational, electromagnetic, nuclear, and weak forces. And finally, we'll wrap up with the scope of classical physics and an awesome mind map to help you study. Step-by-step challenge, so stay with me.
Think about what you do every single day. Pushing a wall, lifting that heavy H.C. Verma book off your desk, or, just pulling a door open. Asal mein, every single physical action you exert, no matter how complicated it might seem, is essentially just a push or a pull. That is your baseline definition of a force.
But that brings us to a really massive question. Kya sach mein all these incredibly complex everyday interactions just boil down to a few fundamental forces? It's kind of like nature is playing a giant cosmic chess game. There are millions of possible moves, but only a handful of simple rules governing the whole board. Let's find out what those rules actually are.
First up is the gravitational force. Simply put, this is the mutual attraction between literally any two masses in the universe. The math for this is simple, but so powerful. The formula is F equals G times M1 times M2 divided by R squared. Okay? Isko dhyan se samjho. G is the universal gravitational constant, holding a value of 6.67 times 10 to the power of -11 Newton meter squared per kilogram squared.
So the absolutely crucial point here is understanding its characteristics. Gravity is always attractive, never repulsive. But here's the reality check. It is extremely weak for everyday objects. Like if you and your friend, both weighing around maybe 50 kgs, sit half a meter apart, the gravitational force pulling you two together is basically zero. Isliye tum dono magnetically chipak nahi jate. You actually need at least one incredibly massive body, like the Earth, to genuinely feel it.
All right, let's move on to our second major player, the electromagnetic or EM force. This is the interaction between charged particles. The governing Coulomb formula here is F equals 1 over 4 pi epsilon naught times Q1 times Q2 divided by R squared. Now, notice a key difference from gravity here. Ye force attractive bhi ho sakti hai or repulsive bhi ho sakti hai. It entirely depends on whether the charges are opposite or the same.
Now think about how we actually experience this force in daily life. When two extended macroscopic bodies interact, like when you clap your hands together, you are actually experiencing the vector sum of billions of tiny atomic interactions. Every single proton and electron is exerting a microscopic force, and they all add up vectorially to give you that net force you feel.
And this perfectly illustrates a concept that usually just blows students' minds. Imagine a block resting on a table. The upward normal force F, holding it up, will fundamentally ik electromagnetic force. Literally every contact force you know, tension in a string, friction on the floor, the spring force, they are all just EM forces acting between the atoms right at the surfaces.
So let's quickly compare the two side by side. Gravity operates on a massive macro scale. It's always attractive, but overall it's very weak. The EM force, on the other hand, dominates both macro and micro scales and is incredibly strong. Like kidney strong? Well, according to H.C. Verma, if just a 1% charge imbalance existed in a 1 kilogram iron block, it would create an absolutely unstoppable repulsive force of 1.7 times 10 to the power of 21 newtons. That is just mind-bogglingly huge.
But wait a second. Let's think about this logically. If protons repel each other with this insanely strong EM force, why doesn't the atomic nucleus, which is packed so tightly with protons, just violently explode? Aisa kya hai jo inko bandh ke rakhta hai?
The answer lies at a very specific distance, 10 to the power of -15 meters. Take a moment to really appreciate this number, because it represents an incredibly short, microscopic realm. And right at this distance, an entirely new boss takes over the physics rulebook.
Enter the nuclear force. This is an extremely short-ranged, highly attractive force that acts between nucleons, meaning your protons and neutrons. Think of it as the invisible, silent glue of the universe. It's totally unnoticeable in our daily lives, but within that tiny range, it completely overpowers the Coulomb repulsion, keeping the nucleus perfectly stable.
Finally, to complete our set of fundamental forces, we have the weak forces.
Let's keep this really simple for class 11. This force operates at ranges even smaller than a single proton. You mostly encounter it during subatomic particle changes. For now, just associate it with neutron to proton transformations like radioactive beta minus and beta plus decay. Bas itna yaad rakhna kafi hai abhi ke liye.
So, we've got forces controlling entire galaxies and forces holding together tiny protons, which brings up a really good boundary check question. Kya hum Newton's classical laws, the physics you are literally learning right now, use Skarsectahans to study everything from those massive galaxies down to tiny electrons?
The answer to that lies in understanding the scope of classical physics. Reassuringly, the classical physics we study works perfectly for object sizes greater than 10 to the power of -6 meters. So cricket balls, cars, raindrops, completely fine. However, it completely fails at the atomic scale, where quantum physics atiye. And it also fails when things move near the speed of light, which is 3 times 10 to the power of 8 meters per second. That's exactly where Einstein's relativistic mechanics steps in.
Okay, as your mentor, I highly recommend you take a mental picture or even a screenshot of this right now. This definitive mind map beautifully summarizes everything we've talked about today. It is pure gold for your JEE or NEET prep. You've got gravitational, electromagnetic, nuclear, and weak forces, their ranges, their natures, all in one clear place. Master this, and your Chapter 4 foundation is absolutely set.
Let's wrap this explainer up with a super actionable study tip. Write these 4 forces and their ranges down on a sticky note and stick it right on your bathroom mirror. Bina effort ke yaad ho jayega, trust me. If this session helps clear up your concepts, please drop a like and subscribe to the channel for more chapter breakdowns. But before you go, I want to leave you with a provocative thought. If gravity is mathematically the absolute weakest of these 4 forces, how does it end up being the very thing that structures our entire universe? Think about that. Keep studying hard, and I'll catch you in the next session.